Hey everyone, this is a bit of a bonus tutorial for PACE-tomo, quickly illustrating what happens if you are a pro user and you turn guidance off in the select target script. And this will speed things up a little bit, meaning that you will have less message boxes to click and you can control more of the actual functionality with just the keyboard shortcuts. So let's set everything to false here so we can use the default target selection. All right, here we go. We're going to run it. I haven't set up any group of points, so we will have to manually drag around, but that should be fine. All right, we have deactivated move stage for big mouse shifts. We can select the folder. Oh, there's no item. Okay, so that means that might be a bit of a bug. So if there's no item whatsoever, it will actually not work. But no fear, we just add a point and it should work just fine. All right, here we go. Group of points. No, I don't want to use this group because it's only 1 point. Let's call it Pro. And here we go. So as you saw, no message popped up and it immediately went into the dragging mode right from the get-go. If you forget what you have to do, there is a little note in the log file. So you can go around and let's say we want to go a bit further, but if you now press B, it will actually take a preview image. So you have to press B and immediately afterwards V. And that will actually cause it to take another view image instead of asking you every time. So let's focus on this blob here, for example. Let's hit B, and if I just wait, it will go automatically to taking a preview image. So no nasty little annoying message boxes to confirm every little step, but you have to be fast. If you want to refine, you have to immediately press R after the preview image was taken, and then it lets you drag around a bit, and then you can hit B again. So if you don't do that, it will immediately go to the save state. It will still ask you if you want to save it, just for confirmation, and then it will go automatically back to the view mode. It will either way take a view image for the first target for the realign procedure later, but after that it will go back to the dragging mode without like telling you again. Just leaving a note here. All right, let's go. Let's drag it a bit, and now I'm just gonna hit B once and it will just take a preview image, and as you can see, if I don't press R in time, it will automatically go straight to the saving window. And the time you have to press the second key after the first one is 1 second. I feel like this is a good middle ground because if you don't want it, 1 second is not too long to wait, and 1 second is at the same time long enough so you can quickly decide if you want to take that step now. The rest is pretty much similar. The only other difference here is you can see if you say no to saving a target, or if you want to stop the target search, you have to press F right after saying no, and that will finish the target selection. Let me see if I can do it here. So I'm going to do BVF, and that should finish it. All right, so that was just a quick little video illustrating this additional advanced feature. Okay, while I'm at it, let me show you another advanced feature that you might want to use if you want to set up a target pattern, but you do not have a regular holy grid or a holy reference in buffer P. And this you can do when you set the target pattern to true, but align to P to false. And then we can set whatever, let's do a 7x7 here. And if there's no align to P, it actually won't be able to determine the vectors from you dragging around and aligning to the holes. So in this case, you can manually set the vectors here. I'm just gonna set to 0 and 0, 2, and you can run the script. Yes, yes, let's call it 7x7. And in this case, it will take a target image, and then it will just set up the rest without asking you. And there we go, 7x7 in the exact precisely defined vector you want, just in case you don't have a reference buffer to align to. I guess while we're talking about advanced topics, we might as well go through some of the advanced settings in the actual PACE-tomo script. I talked quickly about the CTF find versus CTF plotter discussion in the target pattern setup video, but again, CTF plotter is more robust, especially for tilted images, but it is slower. So normally it's not necessary. Maybe in the future when there will be some additional speed up, it might be worth to only run CTF plotter. The fit limit and the parabol threshold is actually interesting for the georefine routine. Just to remind you, the georefine routine uses the focus estimation by CTF find or CTF plotter of the first start tilt image, the proper record image, and uses the Z value to refine the geometry. And the fit limit excludes any CTF fits that fit to a resolution worse than this in angstrom, of course. And the parabol threshold is actually how many successful points it needs to fit a second order paraboloid, basically. So it will adjust for more of the waviness of the support film rather than just a simple plane. And of course, the bigger your target pattern is, the more points you have automatically. And 9 is like the minimum I would use. It's just 3 by 3. And if one of the CTF finds fail, it will automatically reverse back to a plane. But to be honest, it's only worth it for like 7 by 7 or larger patterns to actually do this. So you might want to set this even up higher if you want to. The image shift limits is the serial EM property to limit the maximum image shift in total, which is by 15 by default, but if you want larger patterns, it might be worth raising that to about 20. However, most microscopes, most Thermo Fisher microscopes at least, are hardware limited at 25, and the actual value is a bit lower because some of that hard limited image shift is already used for alignments of the microscope itself, so you might only have around 22 or 23 microns of actual image shift to use, but that depends on your system, of course. Data points is the number of shifts that it uses, like the specimen movement throughout the tilt series. The last 4 it usually uses to estimate the geometry and use it for the prediction of the next specimen movement. You can raise that or lower that. I have not played around too much with it. 4 seemed to work quite fine from the start. The line limit is not so important either. It just means that if it finds a cross correlation larger than 0.5, it will actually ignore that, because usually it should not be 500 nanometer off. And that just helps in case you have like a big ice chunk that moves a lot, or if you just turns black and you have like arbitrary shift, you don't want that to throw off your prediction too much. The min counts is a minimum threshold of mean counts per exposure time at which it will stop the tilt series for a certain target. Let's say if you're in a lamella and the lamella edge comes in at 30 degrees or whatever because you picked a target close to the edge, of course you don't want to collect all the way to 60 degrees just black images. So once it falls below this threshold, it will stop this branch of the tilt series. The split log is useful if you have tons and tons and tons of targets. Like in my large ribosome dataset, I had 121 tilt series, and the log just gets out of control with that many targets and that many images being taken. And for some reason, when serial writes to the log, it actually gets slower and slower the bigger the log file becomes. So it's useful to split it up to actually don't lose time on the microscope just to writing to the log. Then we have the ignore negative shift. It's the first negative tilt shift. I set this to true in the very beginning. I've not played around much with it. It seemed to help at the time, but I haven't experimented with it lately. Slow tilt means that it will not just tilt from -40 to +40. It will actually have an intermediate backlash correction step almost. Because when you use side entry holders, these large tilts make it actually less precise. All right, then again on the side entry topic, you can use slightly different tilt axis offsets for positive and negative shifts. That was just a way for me to compensate for some of the weird behavior I noticed on the side entry holder, where I actually got a different focus slope depending on the positive tilts versus the negative tilts. And this helped to combat that. Normally, you should not need these features. Then last but not least, we have the extended MDoc, which just writes some additional information like the specimen shifts and the CTF find results into your MDoc file. You don't really need that, but it's a nice thing to have. So I gave you the option to disable this if you don't want that. And the check doer is actually interesting. So if your microscope does not have an auto refill doer, you might want to turn this to false. I noticed a weird, I don't know if it's a bug, but if I run it on a microscope, on a gel microscope without the doer, instead of actually giving it a value back, like this function, it will just stop the script without any error message. So in these cases, if you notice behavior like this, you might just want to turn this to false. But on the normal Thermo Fisher microscopes, this is not an issue. I haven't tested it on a cryo arm yet. I'm curious how this will work on a cryo arm that actually has the do a refill function. Anyways, that's it for all the advanced setting that I could think of surrounding PACE-tomo. I hope this helps. Let me know if you have any questions, and good luck for your own collection. Bye-bye.